Okay, here's an example of a problem that's a grid-in problem, not a multiple choice. But again, it's something that I'm able to use to make up numbers strategy because it is about relationships. So let's examine how. So here the P, R, and S all have to be three different prime numbers greater than 2. So again, I'm going to go in and pick the easiest possible that I can think of. So I'm going to pick P to be 3, R to be 5, and S to be 7. So when I do that, I will get a product of 105. So the question asks, how many positive factors, including 1 and, in this case, 105, would 105 have? So over here, I'll make an organized list of all the factors that I can think of 105. So obviously we have 1 in itself, 3 and 35, 5 and 21, and 7 and 15. And if you think about it and you keep going, that would be the only possible factor groups of 105. So you can see altogether, I have 8 different positive factors in this case. And in reality, there's really nothing special about picking 3, 5, and 7. Again, I really could pick anything I want. In fact, why don't I do another one just to prove that to you? So let's say this time instead of 3, 5, and 7, I go with the next combination. I'll do 5, 7, and 11. So when I do that, that's going to give me 77 times 5, or 385. So if I go in and you can kind of see what's happening, why that is, because if I go in and make the list again, you're going to obviously have 1 in itself. That will be 2 of them. But then I can go in and I can do each of the different 3 individual prime factors, and then the other 2 multiplied together is going to have to come to 385. So you can see I'm going to have 3 combinations of that. So I'll have the 5 times the other 2 multiplied together, 77. I'll have the 7 times the 5 and 11, so 7 times 55. And then I'll have the 11 times the 5 and the 7, so 11 times 35. Okay, so obviously, once again, you're only going to have 8 factors. So there you go. Final answer to that, therefore, would be 8.